Okay, now we start exercise 2.3. Our first question is differentiate this function with respect to x. So question number 1 is x4 plus 2x cube plus x square. Let f of x is equal to x4 plus 2x cube plus x square. We just here allocate this name. Now applying derivative on both sides. When we apply derivative on both sides, this f of x will become f prime of x, and on applying right hand side, the derivative will apply on this whole function. According to some theorem of differentiation, this derivative will apply separately on these three terms. So derivative will apply on x4, derivative will apply on 2x cube. But as we know that when we derivative apply on cf of x, then this constant 2 will become outside this derivative, and derivative will apply only on x cube plus d by dx x square. By using power rule, the derivative of x4 will become 4 into x raised to the power 4 minus 1, which will become 3, plus 2 into the derivative of x cube will be, by using power rule, this will become 3 into x square plus derivative of x square, again by using power rule, that will become 2x 2 minus 1, so that will become power 1. So the finally answer will become, or derivative of the given function will become 4x cube plus 6x square plus 2x. Again, almost the same question. Using power rule, we have to differentiate this question. X, we allocate the name, let f of x is equal to x raised to the power minus 3 plus 2x raised to the power minus 3 by 2 plus 3. Differentiate both sides, so left side will become f prime of x, and applying derivative on right hand side. Again by using some theorem, derivative will apply separately on these three terms. So dy dx of x minus 3 plus derivative will apply on 2x raised to the power minus 3 by 2, and derivative will apply on 3. Using power rule, that will become minus 3x raised to the power minus 3 minus 4, so that will become minus 4. 2 will be unaffected, so come out to the derivative. Derivative will apply only on x raised to the power minus 3 by 2, and plus, this is a constant term. As we have proved, the derivative of a constant function is 0, so that will become 0. So the next step will become minus 3x raised to the power minus 4 plus 2 as it is. Derivative will apply on x minus 3 by 2. Again using power rule, minus 3 by 2 x raised to the power minus 3 by 2 minus 1. So after simplification, this will become minus 3x raised to the power minus 4 as it is, as we apply derivative on this term. So this 2 will be cancelled out to this 2. Then that will become minus 3x raised to the power. We simplify it by using LCM. Now derivative will apply only on this part. This minus 3x raised to the power minus 4 will become as it is. That will become 2 into minus 3 by 2 x raised to the power minus 3 by 2 minus 1. The next step will be minus 3x raised to the power minus 4. This 2 will be cancelled out, so that will become minus 3x. We simplify it by using LCM, so that will become minus 3 minus 2 divided by 2. So the final answer will become minus 3x raised to the power minus 4 minus 3x raised to the power minus 5 by 2. Okay, the next question, differentiate this function with respect to x. We start this question by allocating this name. Suppose that is f of x is equal to a plus x over a minus x. As this is a quotient thing, f of x over g of x, so when we apply derivative on both sides, Left side will become f prime of x. Derivative will apply on right hand side. So here we apply quotient rule. And the quotient rule was just square of the denominator g of x whole square, g of x as it is, derivative apply on f of x, which is numerator, minus, then f of x will be as it is and derivative will apply d by dx on g of x. So when we compare this to this step, this denominator will become in the form of square, so a minus x whole square. Derivative will apply on f of x, which is a plus x. G of x will be as it is, which is a denominator function, minus, then f of x will be as it is, a plus x, and derivative will apply on denominator, which is a minus x. As this a is the constant term, so when we apply derivative of a plus x, then by using sum theorem, derivative will apply on a and derivative will apply on x. As this a is the constant term, so derivative will become 0, and when we apply derivative on x, so that will become 1. So this is the result. Derivative of a will be 0. We have only 1 by using derivative of this x. This a minus x will be as it is, minus a plus x, and similarly when we apply derivative on a minus x, that is a constant term, will become 0 after applying derivative, minus x, derivative will apply on x will become minus 1. So after simplification, this a minus x whole square will be as it is. A minus x by multiplying 1 will be a minus x. This minus and this minus will become plus a plus x. A minus x plus a plus x. This minus x and plus x will be cancelled out. So the final answer will be 2a over a minus x whole square, which is actually derivative of the given function.